transfer. Enhanced interior gateway routing protocol. Right. Fine. Right. Any other points from anyone? EIGRP sends the hello packet, including the authentication string. Once authentication is done, only then the neighborship establishes and the updates will be sent. சரவண மாத்தி சொல்லிட்டார். அப்டேட் அனுப்புறதுக்கு முன்னால அத்தன்டிகேட் ஆகுன்றது சொல்றதுக்கு பதிலா என்ன சொன்னார் அவரு? அத்தன்டிகேஷன் என்ன சொன்னீங்க? What did you say? சரி, anyway, correct it. First, the hello packets with authentication. The hello packets will have the authentication information. They need to first get authenticated. Once authenticated, the neighbor is accepted. Once the neighbor is accepted, whatever the neighbor you have learned, to all neighbors, you will send whatever the update you have got. Yeah. All the updates are sent. Very nice. See, IGRP administrative distance is 100. It is not EIGRP, IGRP. Administrative distance is 90. This is the older version. This is no more available in many devices. All right. EIGRP is an advanced distance vector protocol. You see, few may not be agreeing with this advanced distance vector protocol. If you are appearing for a CCNA level interview, they will not accept this. Because in CCNA books, it is written as hybrid protocol. Hybrid routing protocol. But I tell you, when you go to higher levels like CCNP and CCIE, you will see advanced distance vector protocol. The reason is, in CCNA, they don't go deep into EIGRP, so they couldn't justify this point. So they simply say a hybrid protocol. Why hybrid? You will see something like RIP. You will see somewhat like OSPF, like both mixed together, hybrid. But in reality, if you see the working principle, this don't have anything related to OSPF. So you cannot call it as a hybrid protocol. This EIGRP has got no traces like OSPF. EIGRP has got no traces like OSPF. So you cannot call it as hybrid protocol. You can call it as an advanced distance vector protocol because this works similar to RIP. But it is advanced than RIP. For example, how many hops RIP support? But 15, 16 is infinite. This one, by default, it can support 100 hops. And you can tune it even up to 255 hops. Yeah. So EIGRP is an hybrid routing protocol. That's a CCNA level of answer. Advanced distance vector protocol is the right way of calling EIGRP. So when an interviewer asks you a question, even if it's CCNA or CCNP level interview, it doesn't matter. You try saying this answer advanced distance vector protocol. If he disagrees, then you say it's a hybrid protocol. Don't argue with him because he may not be aware of CCNP syllabus. He is trained only to CCNA level syllabus, that HR questioning, or he may have a ready-made question answer paper with him. Never mind. Now, EIGRP is an advanced distance vector protocol. Why it is called as advanced distance vector protocol? Same like RIP. They advertise the network and the metric. You see, RIP used to advertise like this. Let's say you have 4.4.4.4. This will advertise saying 4.4.4.4 is one hop. For me, it is 0 hop because it is connected directly. Whoever receives it, for them, it is 1 hop. And R3 will say, yeah, for me, it is 1 hop. It learns. Whatever R4 says, it will believe. It learns 1 hop. Now, R3 will advertise saying, for me, it is 1 hop. Whoever receives it, it is not sending to R2. It is sending to a multicast address if it is version 2. So it is not precisely sending to router 2. It is just sending the update via this wire, via this interface, via this link. Now the update comes to router 2. And router 2, this is saying for you it is 2 hop. So it learns as 2 hop. And this will say for me it is 2 hop, for you it is 3 hop. So router 1 will learn like this. 4.4.4.4 is 3 hops. So from the routing table, see here it is 0 because directly connected. Based on the routing table info, whatever the route that is there in the routing table is advertised. Here in the routing table it is 1. So it takes that, adds 1 to it and advertises. This is how a distance vector protocol behaves. It shows how far 3 hop away. In what direction? This direction. So it shows both the distance and direction. EIGRP is an advanced distance vector routing protocol. Advanced distance vector. The reason is it is not just sending hop count. EIGRP metric is a little bit composite. Yeah, composite, meaning it is going to take the bandwidth and delay. It is going to take the bandwidth of the wire and the delay of the wire to derive a metric. Why do I put K3 and K1? That is how in the formula bandwidth is identified and delay is identified. You remember we saw an algorithm called dual. The diffusing update algorithm has got K values. K1 means in the algorithm bandwidth. K3 means delay. K2 I did not write. The reason is it is not considered, which is reliability. No. Load, not considered. K4 again not considered, which is reliability. K5, which is also not considered, maximum transmission unit. Though there are 5 parameters in the formula, EIGRP currently considers only these 2. It considers these 2. According to these 2, a number will be derived as a metric. The path with the small number, the derived small number, is the best path. See, if you have multiple paths, for all paths you will be having bandwidth and delay. Delay to reach that destination, how long it will take, and the bandwidth. All paths will have this bandwidth and delay. Now, by taking the bandwidth and delay of both the paths or all the paths, it derives a composite value for each path. For example, from R1 to R5, to go via this path, depending on the bandwidth, to go via this path, the composite value derived is 15. The composite value derived in this path is 50. So EIGRP will consider this path only. Why? Even though there are many hops, it won't consider hop. It is focusing on the bandwidth. This is 10 gig links. This is just 1 gig link. Obviously, when the bandwidth is high, delay will also be low, isn't it? When bandwidth is high, delay will be low. When bandwidth is high, delay will be low. So the path with the less composite value, when bandwidth is high and delay is low, you will get less composite value. The path with a less small composite value will be considered. Yeah. All right. So we got only 2 K values out of 5. This is an advancement. You see, you will also agree with me when I say advanced. One reason I already told you, by default it supports 100 ops. The other reason I'm showing you here, if it is RIP would have said this is the best path. See the bandwidth. Is that a clever idea? No. EIGRP focuses on bandwidth and delay. Now your mind may say now, then why did we learn RIP? RIP is not good, you know. It is seeing only hop count, not focusing on bandwidth and delay. See, depending on the situation, the importance will be given. In some situation, you may not be willing to focus on bandwidth and delay. You want to only see the hop count. When we come to CCNP, I'll give you a nice example with VPN. Then RIP is good because you're focusing only on a hop count. But in some situation, you don't want to focus on hop count, you want to focus on bandwidth and delay. Then EIGRP is best in that environment. So depending on your requirement, that is why we learn all protocol. We will use whatever suits your requirement. All right. EIGRP is an advanced distance vector protocol. 2 reasons I have already given. There are much more coming later. Now, administrative distance 90, you already know. And I already taught you yesterday how often the hello packets are sent. Do anyone remember? Exactly. Every 5-second hello packets are sent. If a neighbor stops sending hello packet for 15 seconds, the neighbor is considered dead. Please book this. Now, when it comes to administrative distance, there is also one more number, which is 170. Please understand what I'm trying to say. EIGRP is an IGP protocol, meaning this is a protocol that is meant to be within the organization. But from internet, if someone gives you a network to advertise inside your organization for some reason, I repeat, you want to learn roots of Yahoo, Google, Facebook in all your router. So what we do is we redistribute from BGP into EIGRP. Now, who is the owner of these networks that is coming in? Not EIGRP. Someone somewhere in the internet, some protocol. Somewhere it is coming via a protocol called BGP, Border Gateway Protocol. So when you take the BGP route inside EIGRP, we call it as redistribution. You see the word itself explains. Distribute means what? Giving. Redistribute means what? Giving again. Giving from BGP to EIGRP. That's an example for redistribution. Now those redistributed routes will have 170. Please understand, within the organization you have many networks. Those networks will have 90 only. Those networks learned from EIGRP, those internal networks will have 90 only. But the network which is coming from outside the autonomous system, outside it is coming, but it will not be coming from EIGRP, because outside we don't use EIGRP. Outside we use BGP. That's why it is called as Border Gateway Protocol, BGP. Border Gateway Protocol. That works in the border. Learn from another autonomous system, give it to you. Now, when you take those external route and redistribute into EIGRP, those outside networks, EIGRP will give administrative distances 170. What does that mean? ஐயா என்ன நம்பாத எக்ஸ்டர்னலுக்கு என்ன நம்பாத per 170 OSPF நம்பிக்கோ BGP நம்பிக்கோ OSPF எவ்வளோ 110. You can trust OSPF, which is 110. You trust any other protocol. Don't rely on EIGRP, because EIGRP is not meant to be the protocol that works outside. This is a protocol for inside. So for inside network, I give guarantee 90. Trust me, trust me, trust me. But for outside network, if there is any other source for you, better rely on that. You understand this 170? So 170 is external, 90 is internal. That is what I want to show you here. Let's go to router B and type what protocol, what is the command to see the routing protocols that are running on this router. Well done. Let me show you that. Let me take another router. Show IP protocol. You see, internal is 90, external is 170. You see the K values? EIGRP metric weights are K1, K2, K3, K4, K5. Can anyone recall what is K3? Delay. K1 is bandwidth, K3 is delay. Meaning, you see, for other, it is 0. For other, it is 0. Only for this, it is 1. What does that mean? Bandwidth is multiplied by 1. What you will get? Bandwidth only. If there is 1000 meg, 1000 multiplied by 1 is 1000. But if you multiply load with 0, what will be the answer? Load multiplied by 0. I told you, K2 means load. Load, if you multiply by 0, what you will get? 0 only, which means they are not considered. And then reliability, not considered. MTU, not considered. If you take any wire, you will have these 5 things. Let me show you that. Show interface G0/0/. You take any interface, you will have that 5 K values. K1, K2, sorry, K1, this is K2, load, transmit actually, transmit. 1 by 255. 1 is the load. Bandwidth, load, delay, K3, reliability, K4, MTU, K5. Every wire will have these things. Now let's go back. Right. I just showed you that the other K values are not going to be considered. But if they ask you a question, can we make them consider MTU? Why not? Yes, you have an option. But if you will do it on one router, that's not enough. You have to go and do it on every router. You see, by default on every router, these two are on. You saw that. Now, if you go just only on one router and consider MTU and can say consider MTU, what will happen? The other routers will conflict. So if you do it on one router, not enough. You have to do it on every router. Otherwise, they won't form neighbor. The K value should match. K values must match to form neighbor. So don't change the K value. Let it be K1 and K3, which is default. But if there is a situation, I don't think there is a situation like that in the real world. In case if there's a situation where you want to consider MTU also, then you can go and turn on. Okay. Now, we saw EIGRP as a classless routing protocol that uses only multicast address. The multicast address that EIGRP uses is 224.0.0.10. Do not forget, this is never going to change. Will always be the same. It's reserved. Industry-wise, it is reserved. It is given to Cisco to EIGRP protocol. Cisco only can own this. All right. Now, this one protocol, I told you it can maintain topology table. If I have multiple paths, this path and this path. In this router's routing table, you will see only one path, the low metric path. But in the topology table, you will also find alternate path. Yeah, you will also find alternate path. Okay. We call it as topology table because it shows the topology itself, right? Okay. Now, when we come to CCNP, we will be speaking more about the topology table and the alternate path. It's not that easily going to be selected as an alternate path. There's a criteria. There's a constraint need to be satisfied to become a alternate path. Say, for example, I just give you one example. Later, we will see technically when we are in CCNP syllabus. You see, from here to Tiruvannamalai, this route is, let's say, 102 kilometers. To the same Tiruvannamalai, you have this route which is 1,000 2 kilometer. Will you consider this as a alternate path? No. You will wait in this path till the traffic gets cleared and then you will go in this path only. Because of traffic, you won't take diversion. The criteria is not met. This is too much. All right. Why I'm saying this, in interview, if they ask you, will all alternate paths seen in the topology table? Answer is not always right. Answer is not always yes. There is a condition to be met for an alternate path. If the condition is not met, it cannot be used. Okay. So far we have these things: multicast address, hello timers, dead timers, MTU. Okay. EIGRP supports equal cost multipathing like all protocol. It also supports unequal cost multipathing. What does it mean? Every protocol supports this one. Even RIP supports this. For RIP from R1 to R2, if you want to go, how many hops? 1, 2, 1, 2, 1, 2. They are considered as equal cost multipathing. So R1 will use all three paths to reach this destination. R1 will reach R2 via all these three paths. RIP will use all three paths in the routing table. Whatever the route is in the routing table, router is going to use. Now, unequal cost load balancing or unequal cost multipathing means what? For RIP, this is not possible to use. RIP will only use this path. It will never consider this path which has got 1, 2, 3 hops, 1, 2, 3, 4 hops. It won't consider. But EIGRP can consider. EIGRP anyhow, it is not going to focus on the hop count. I'm just talking about metric. Let's say this path metric is 15. This path metric is 15. This path metric is 15. EIGRP will use all three paths to share the load. But EIGRP can also do this unequal cost multipathing, but not by default. By default, it is going to say, I will use the low cost path. For these things, we need to configure variants. We'll talk about that when we come to CCNP. This is our CCNP syllabus, but I'm just telling you, the EIGRP protocol is advanced. We say advanced distance vector. These are all the reasons. It can even support unequal cost load balancing or unequal cost multipathing. Well, all are same. Load balancing means what? You distribute the load across multiple paths to balance the load. EIGRP can support unequal cost load balancing or unequal cost multipathing. All right, fine. That's about very special of EIGRP. See, no other protocol on earth No other routing protocol on earth can do load unequal cost load balancing. Yes, it's only EIGRP, so it's very special point. Next, EIGRP will never do broadcast. I told you there is only multicast and unicast. And what are the tables EIGRP maintains? As usual, routing table and topology table and neighbor table. Okay, what else? EIGRP uses autonomous system number. I told you that also. Now, if I have one router connecting to another router, connecting to another router, or 3 or 2 and R1. If you have this 3 router, and let's say this is running EIGRP 10. This is running EIGRP 10. This is running EIGRP 20. Will I be able to ping from 3.3.3.3 to 2.2.2.2 and 1.1.1.1? No. Why? Because they don't form neighbor when the autonomous system number is different. This autonomous system number is 10 and this is 20. Will they form neighbor? No, they won't form neighbor. They don't form neighbor. When the autonomous system number is different, they don't form neighbor. These two will form neighbor, they share. Router 2 can ping from here to here, no problem. Any question here? Why are you silent? Please ask me some question. No questions about the autonomous system number? Okay, then I'll ask you a question. What if I do not want to change the autonomous system number of router 3, but I want to ping from R1 to R3 without doing any change? Meaning I do not want to change the 20 to 1. I do not want to change 20 to 10. I don't want to change. I don't want to change from 20 to 10. But I want to have EIGRP to form neighbor. This is the way that we do. But this is too far away from the CCNA level. But in CCNP level, this is important. But I'm just telling you now. Again, I'll repeat you when we go there. You see, we can run more than one EIGRP. So what I'll do, I'll go inside EIGRP 20 and advertise this 20 network. And I'll go EIGRP 10 and advertise this 10 network. So this 2020 will form neighbor, this 1010 will form neighbor. But the routes of 20 will not go to 10. The routes of 10 will not go to 20. They don't go. They don't go. If you want them to go, if you want to make them go, you have to redistribute. We need to redistribute. What is redistribution? Taking from EIGRP 20, giving it to EIGRP 10. And taking from EIGRP 10, giving it to EIGRP 20. Like I said earlier, you're taking from BGP to EIGRP. That is redistribution. This is also redistribution. So according to router 1, in the routing table for 3333, administrative distance will be 170, not 90. You understand? For 2.2.2.2, it is 90 because it belongs to EIGRP 10. But for this 20 network and 3.3.3 network, it will be 170 because you are doing what? Redistribution. Redistributed networks will have 170 as the administrative distance. Is that clear? Mhm. Like, very good question. See, you should not call this as process ID. Why? I just told you these two should match to form neighbor. You try to understand the word process ID. Process ID. Let's say you are applying for a visa. They'll give you the application number. With that only they will process. Is that application number same for others? No. It's local. It is local. It's your application number. But the visa office have got an internal ID or number. Let's say the ID number, location 50. That's the passport office number. Internally, they use that number, assume. For all the applicants, that ID will be same because all the applicants have appeared in that particular branch of passport office. You should not call this as process ID. Why? It must match. It is to identify who all form one autonomous system. If the number matches, meaning we belong to same group, same autonomous system number, same autonomous system group. So in this picture, you have two autonomous systems. This is one autonomous system. This is another autonomous system. Sorry. Two autonomous systems. You should not call autonomous system number as process ID. EIGRP has got autonomous system number, not the process ID. Let me show you again on this router. Show IP protocol. You see, this 100 is an autonomous system number. And when I try configuring, you will see that. Router EIGRP, put question mark. What does it say? Does it say process ID? It is an autonomous system number. And this number must match with a neighbor router in order to establish neighbor. But in OSPF, that is the next protocol. In OSPF, I want to show you now. Router OSPF. In OSPF, it is process ID. In OSPF, to identify the OSPF process locally on the router, like your application number, this same range, like 1265535, same range, but this is OSPF, so it is process ID. That is EIGRP. That is autonomous system number. In OSPF, this number that you're going to type here doesn't need to match with the neighbor. Not necessary to match. Neighbor will come up even if the number doesn't match because it is just locally significant process ID. Locally significant process ID. Locally significant process ID can be same or can be different, doesn't matter because they don't share this number with the neighbor to compare. But autonomous system number is always shared in the packet so that the neighbor will open the packet and see whether that router and me belong to same autonomous group. After seeing that only they will form neighbor. Did everyone understand the difference between autonomous system number and the process ID? OSPF uses process ID, EIGRP uses autonomous system number. Oh, right. Now we'll focus on wildcard mask. What is wildcard mask? In EIGRP, we should learn this one because this is not there in RIP. Wildcard mask is just the opposite of subnet mask. What is the subnet mask for this? 255.0.0.0. The subnet mask is this. Sorry, the wildcard mask is this. This is wildcard mask. This is subnet mask. What does this mean? It means if only first octet has 0, which means even if this address is 10.1.1.1, only focus on this one. That is the meaning. Match. 0 means match. The first octet should match. Where? Match on the interface IP. The other octets don't care. If you have done some physics or mathematics or computer science degree, you might have heard about don't care bits, the Boolean values, all the stuff. Let's not talk about Boolean, but here I'm talking about don't care bits. Now, why it is important in EIGRP? Say, for example, in RIP, I have one interface with 10.1.0.1 IP /16, 10.2.0.1 /16. This is router 1. Now, if I want to run RIP for both networks, how will you configure? Can anyone help me to write the command? How will you configure if you want to advertise this both to router 2? You will say router RIP version 2. Why? Because they are subnetted. And then by default, they will summarize and send 10.0.0.0. You don't want to summarize, so you will say no auto summary. No auto summary. And then if you say network 10.1.0.0, it is not going to accept as 10.1. It will accept as 10.0 only. I showed you this when you were in RIP class. Even if you give 10.1, it will not consider as 10.1. It will take it as 10.0.0.0. So what happens is, even if you give network 10.2.0.0, both will be taken as just 10.0.0.0. So what do you have to do? If you don't want to advertise this, I repeat, what you have to do if you don't want to advertise this, listen carefully. I repeat, if you put 10.1, it is going to take 10.0.0.0. 10.2, if you put also, it is going to take 10.0, which means what? It will advertise both the networks. RIP will advertise both. But I don't want this to be advertised. I don't want R2 to ping this computer. I don't want R2 to reach this network. I want R2 accessing only this network. In RIP, you don't have an option. You have to write a lot of filters to do this. Complicated. In EIGRP, it is easy. In EIGRP, we say router EIGRP, autonomous system number. And if you don't want to advertise this, what you should do, you should say 10.1.0.0.0.0.255.255 network. You see? Which means match 2 octet, and if the match is found, advertise only that. Will this match with this one? No, because 2 octet you have asked to match. 2 octet, is it matching 10.1? No, not matching. Only this matches. Only this will be advertised. Did you understand the usage of wildcard mask? Now, what about others? What about others? If you're confused, we are going to do this lab. Listen, I'm going to create some subnetted network. Say, for example, I'm going to take here 100.1.1.1 on loopback 0 interface. Loopback 1 interface, I'm going to say 100.2.2. Loopback 2, I'm going to say 100.3.3.3. And then with EIGRP, I want to advertise only this too. See how I am doing. Listen carefully. I'm on Dr. A. If you focus, you will understand. When time goes more than 45 minutes, you lose focus, I think. Let's start with one only. Okay, interface loopback 1, IP address 100.1.1.1. Interface loopback 2. Interface loopback 3. Done. You see, if I go to RIP, router RIP, and say network 100.3.3.3, see how it takes. Show IP protocol. It takes 100 only. It will not take 3 and all. It will advertise all 3. It will advertise all 3. That is RIP. I'm showing RIP. Please focus. I'm showing RIP first. Actually, I went under RIP and said 100.3.3. It is not obeying me. It's simply saying classful. Though version 2 is classless, it takes mask as classful only. Now, I'm going under the EIGRP, router EIGRP. What is the autonomous system number we gave yesterday? 100. Okay, 100. I'm going under EIGRP, and I'm going to say advertise only 10. If I simply put 100, see what happens. If I simply put 100, see what happens. I'm saying 100. Go to router B, you will see all 3. Show IP route. You see all 3. All 3. But my aim is not to advertise this. So what I should do, I should remove the old config. I should not have 100 here. Instead, I'll say network 100.1.00. I'm saying the second octet must be 1. And then so this means that only if this matches, you advertise. Otherwise, don't advertise. So this will not match with 3. So when you type show IP EIGRP interface, it is not showing loopback 3. Why loopback 3 is not shown? See, show IP interface brief. EIGRP is not running on loopback 3. Why? Because it is 3 here. We have said match only 1 and 2. Now if you go to router B, earlier when you check you saw all 3. But now 2 is gone. Sorry, 3 is gone. You see, 3 is gone. Did you understand the power of wildcard mask? You don't need to do any filtering job. Just advertise with the wildcard mask correctly. You understood, everyone?